Next experiment is, again, has to do with heat, and what we're going to do is measure how much heat. So when you dissolve a solid into water, it requires energy to do that. Now, the energy there might be energy released when this reaction takes place, when these substance gets dissolved, or it might be actually energy may be absorbed. So what will happen if energy is given off when a substance is dissolves in water? It will heat up. It'll get warmer. Now, what we're going to see also is that there's some substances when you add it to water, it actually cools it down, like ice. Okay, and we're going to do 2 experiments. And what we're going to do is we're going to have 2 substances, potassium nitrate and ammonium chloride. And what we're going to do is find out how much energy requires to melt them, either being given off or heat energy that's being absorbed. So, like the ice one, what we're going to do is we've got to measure out the mass of water. And so I'm going to put on my cup, hit 0, and I got some water here. Okay, hopefully you guys see what I'm doing. Okay, and I'm going to add water. It's about, I don't know, 130 mils, but that doesn't matter. Okay. So 128.19 grams of water. Okay. Okay. So now what I'm going to do is I'm going to measure out between 5 and 10 grams of potassium nitrate and put it into water and find out what happens to the temperature of the water. If the temperature gets warmer, that means this reaction is giving off heat to take place. But before I do that, I want to get initial temperature of my water. Because what I'm going to do is I'm going to take that potassium nitrate, and I'm going to put it in the water and stir it up, and the temperature go up or down. Hopefully, it doesn't have to, but I want to record the temperature change. Okay. So this thing here is called a weigh boat, and we'll 0 it, and I'm going to so I don't know, maybe 5 grams if I can, or thereabout. So I have 3.3. So these are tiny little pellets. 4.2. Okay, let me get a little more. I don't have to get exactly 5. I'm just they kind of roll off of the. That's good. So 4.93 grams of potassium nitrate. And now I'm going to add that to the water. Initial temperature is 20.0. Okay. I add it. And what I do now is I stir it up. Okay. Again, I keep the top on. So only heat that's giving off heat, the heat will stay inside the water. It won't heat up the air. the temperature's gone down a little bit. So it's not giving off heat, it's actually taking in heat to melt the solid. And there's still some in there I can see. Still some in there. It's going down about 18. So it's going to stop going down. As soon as it all dissolves, there's nothing to change the temperature of the water anymore. Okay. I think it stopped going down. And we'll say the final temperature is 18.0. Okay, so that's it. So that's what we have to know. We have to know the mass of the water, the mass of the potassium nitrate, the initial temperature, 20.0, and the final temperature, 18.0. So the temperature went down because the ammonium nitrate, the potassium nitrate absorbed heat from the water to melt. And we'll go into the calculations for that. Okay. Right now what I'm going to do is same experiment, this time with ammonium chloride, and see what kind of results it has. Alright, I'm going to do the same thing. So we're going to measure out some water. I'm going to measure about the same. We'll do there. Okay, so that temperature is 100. So the water inside the cup is 111.31. Okay, I'm going to get its initial temperature. Use the same thermometer, so it probably needs to go up to 20 degrees Celsius. It does that. Okay, I'll leave it there as it goes up. Okay, now what I'm going to do is measure out about 5 grams. Again, I say about, but actually what I'm going to do is actually record the exact amount I have. So 0, the weigh boat. So this isn't quite as dense. Then I'd have to add more. It looks like more to get 5 grams. So right now it's 4. I'm almost filled it up. Okay. So one interesting thing here is that you'll see the same amounts, how how different they are in changing temperature. Okay, so this mass is for the ammonium chloride is 4.75. And the starting temperature is 20.0. Okay. Stir it up. And temperature going down. Now, not all substance, when you dissolve them, their temperature goes down, okay? For instance, if you take sodium hydroxide and put it in the water, the temperature go up. This is going down much more. Now it's at almost 17. And it's less water, of course, and a little bit less water. Same amount of, almost the same amount of substance. Right, so I think it's completely dissolved. And I'll say 17.2 degrees is the final temperature. Okay. All right, I'm going to do one more. I have to go get it. So it's going to take me just a second. I'm going to do sodium hydroxide. So you got the mass of the water here, the mass of the ammonium chloride, the initial temperature, and the final temperature. Okay. All right, I'm going to go get some sodium hydroxide, and we're going to do the same experiment. I have to go inside the Okay, so now go get some water. So we'll discard the waste. Okay, so I'm going to measure the water. So I'm zeroing the water. So it's the third experiment. So there's 124.64 grams of water. Okay, and let's get initial temperature. Okay, we'll let that go up. Let's measure about 5 grams of sodium hydroxide. So I'm going to zero the weigh boat. So this one's going to take a little longer because you got some pretty heavy duty pellets here. So the final mass is 4.68 grams of sodium hydroxide. Okay, the initial temperature, 20.0. And let's add it. Okay. Okay, now the temperature's going up. Okay, So this guy, when you put it in water, instead of taking in heat to dissolve the solid, it actually gives off heat. And again, we'll figure out how much heat is involved. And it has to do with the change in temperature, and we'll go over that. So, again, this takes a little longer because the pellets are pretty thick. It's already gone up to 25 degrees, so it's sodium hydroxide can really kind of heat up water, and it can be kind of dangerous because of that. If I would just dump a bunch of sodium hydroxide into water, it could almost get it to the point where it's boiling. Okay, so it's about 26 degrees. There's still some left. I don't really like baking the top off, but that's because I'm letting out heat. But I want to see if it's still there. A little longer. Okay. All right, the final temperature of the sodium hydroxide in water, dissolved sodium hydroxide, 28.5, we'll say. Okay. So again, you got the initial mass of the sodium hydroxide, the initial mass of the water, the initial temperature, and the final temperature. That's for all three. And the next thing we're going to do is we're going to incorporate that data to figure out how much heat it requires to dissolve these three salts.